US Physics Olympiad, year 2011, USAPHO, semifinal exam. Problem A4. Solution for this problem you can find below this video in the reference of the description. In this problem we consider a simplified model of the electromagnetic radiation inside a cubical box of side length L. In this model the electric field has a spatial dependence E as a function of x, y, z equal this expression, where one corner of the box lies at the origin of the box is aligned with the x, y, and z axes. Let h be Planck's constant, k be the Boltzmann's constant, and c be the speed of light. Question A. The electric field must be zero everywhere at the sides of the box. What condition does this impose on kx, ky, and kz? Assume that any of these may be negative and include cases where one or more of the ki is 0, even though this causes E to be 0. Question B. In the model, each permitted value of the triple kx, ky, kz corresponds to a quantum state. These states can be visualized in a state space, which is a notional three-dimensional space with the axes corresponding to kx, ky, and kz. How many states occupy a volume S of the state space if S is large enough that the correspondences of the states can be ignored? Question C. Each quantum state in turn may be occupied by photons with the frequency omega equal f over 2 pi equal c multiplied by model k, where c is speed of light and k is length of vector k in this space. If the temperature inside the box is T, no photon may have energy greater than kBT, where kB is Boltzmann constant. What is the shape of the region in state space corresponding to occupied state? Question D. As a final approximation, assume that each occupied state contains exactly one photon. What is the total energy of the photons in the box in terms of H, kB, C, and T, and the volume of the box? Again, assume that the temperature is high enough that there are a very large number of occupied states. Hint: divide state space into thin regions corresponding to photons of the same energy. Note that while many details of this model are extremely inaccurate, the final result is correct except for a numerical factor.